Hi, Wildcats. I just want to take a few minutes and talk about the scientific concept of impulse and how that relates to our design challenge, the chip or package, the Pringle, or whatever you want to call it. Let's take a minute and think about what is actually going to be happening when the chip breaks, or if the chip breaks. And really, I guess we could change that to what happens when anything breaks. So what causes an object to break? Well, we know from previous science classes that that happens when a force is applied. So we want to be thinking about forces here. And like I could take my hand, and if I apply a force to this chip, I'll just crush it. When this car drives into this pole, the pole exerts a force on the car and vice versa that causes the damage to that. So really it's forces that we're talking about. In Newton's second law, we've probably seen it written as F equals ma. At some point you've probably seen that. Newton's second law tells us that how big a force is depends on the mass and the acceleration. Acceleration, really we can think of acceleration is your change in velocity, so over change in time. So that would be like going from 25 miles an hour to 0 miles an hour to stopping. We would be accelerating. And if we measured how long it took to go from 25 miles an hour to 0, that would be our acceleration. So we can really say that the force on an object, Newton's second law tells us the force on an object is equal to the mass by how much its velocity changes and in the amount of time. And so now if we can start to look at this a different way. If we multiply, you're going to use a little algebra here, if we multiply both sides by change in time, time cancels on this side, and we end up with an equation that looks like this. Force times change in time is equal to mass times change in velocity. And this is called the impulse equation. And so really, this is how we need to start to think about things on what causes something to break. We know every object. Your chip has a mass. It's going to, when it moves around, its velocity changes, right? So if it's being carried, it has some velocity, and then if it stops, it has accelerated from some velocity to no velocity. Because it has mass and it has a change in velocity, we would say that it has momentum. And that is equal to the force applied on it to the time. So it's really this time that is really going to be the big issue, because this isn't going to change. I can't control an object's mass. It is what it is. And like your chip, you're not going to be able to change its velocity. So this is going to be some constant number, and the force on it and time will be equal to that number. So really we can think about that force and time are related to an object's momentum. And so I want to look at a specific example to think about maybe what that means and how that's going to affect us in this challenge. So here we have a car, two cars, same. Those cars are 1,000 kilograms and they're both going 20 meters per second. So we could figure out the momentum that those two objects have. It would just be, I just use the right side of my equation here. So it would be 1,000 kilograms times 20 meters per second, or both of those cars have 20,000, and the unit here is going to be just what it is, kilograms times meters per second. So that's how much momentum they have. Now, how that plays out in terms of force and time is different in these two situations. So in this case, when this car drives into a wall, we know that the time for that car to stop is going to be really, really small. So let's just say that the time that it takes this car to stop here is 0.2 of a second. So really suddenly, if a car drives into a wall, it's going to stop. This is a bale of hay, so it's going to take much longer for the car to slow down because this is soft, right? It's squishy. So we would say, let's just pick another number. Let's say that it's 4 times slower, so 0.8 seconds. So what does that mean? Well, just stop and think. Which of these would you rather be in the car for? Would you rather be in a car that drives into a wall, or would you rather be in a car that stops by going into a bale of hay? Every single one of us would pick a bale of hay because we wouldn't get hurt as badly. Well, why? That tells us the force must be smaller. And this impulse equation tells us why. So if we look at this as two different problems here, we can see that the right side of this equation is 20,000 kilograms times meters per second. The left side is different though, because we have different times. So over here, I can solve for the force. How much force will this person experience? Well, the force is going to be equal to, excuse me, their momentum, 20,000 kilograms times meters per second, divided by the time, or 0.2 seconds. And all I've done is just rearrange this algebraically, divide both sides by time to get force by itself. So in this case, the force on this car when it stops by hitting the wall is going to be 100,000 newtons. That's a lot of force. You're going to feel that. On this side, we do the same thing. Force is equal to, we have smaller time, so it's still the same amount of momentum change, 20,000 kilograms times meters per second, but now it's taking us 4 times as long to stop. So 20,000 divided by 0.8 seconds, the force over here, while it's still a big number, 25,000 newtons, it's smaller. It's smaller than hitting this wall. And the reason that this force is smaller is because time is greater. So as time goes up, since this number is going to be the same for both of these, right? Mass and velocity is the same. What happens over here affects force. So the larger the time, the smaller the force will be. And that's exactly what we see here in this example. We feel less force, it's less severe of a force when we stop our car by driving into a bale of hay, because that force is spread out over a longer period of time. Whereas here, the force is larger because time is very small. That is the idea of pretty much every safety device. In gym class, they pad the walls. Why do they pad the walls? Well, because if you run into a brick wall, it's going to hurt. The time will be very, very small. On the other hand, by putting the pads there, those pads gradually change your momentum. It takes you longer to go from whatever speed you have to a stop. And that larger time means a smaller force. Whereas here, time is small, and so I have a big force. And we all know it's going to hurt a lot more for you to run into a brick wall than it is a padded wall. That's the idea behind every safety feature in your car. The reason that your car crumples, and they build crumple zones into the front and back of your car, is because as this section of car crumples, that takes time. And the longer time is spent the car crumpling, the less force you're going to experience. Airbags are there to do the same thing. The more time it takes for you to stop, the less force there will be on you. Seatbelts do the same thing. Every safety feature in your car is built around this idea that force times time is equal to mass times velocity. You can't change the mass of your car when in an accident. You can't change how fast you're going. Well, you can, but after the accident has occurred, you can't go back and change that. So all we can do is try to increase time as much as possible, time of the accident, which decreases force. When you drive down the road, you may have seen those barrels, the orange barrels. They fill them with sand and water. Why? Because if they filled them with concrete, you would suddenly stop, /tiny time. If you fill them with water, the car has to go all the way through there, and it slows it down, which means a much bigger time, which means a much smaller force. So it is safer for you to get into an accident driving into barrels of water or sand than it is into a concrete wall. So hopefully that gives you a better idea of what impulse is. So how does this actually relate to your design challenge? Well, your Pringle, your goal is to keep it intact. And we said, what's going to break it? What's going to break it is going to be the force that acts on it. You cannot change the mass of your Pringle, and you won't be able to directly control how fast its momentum or its velocity changes, right? When you put it in the mailbox, the mail carrier decides whether they throw it down or how they drive in their vehicle or whatever. So you can't control velocity. So this one you have no control over. You don't have control over mass. You don't have control over velocity, and force is what's going to break it. So as an engineer, you need to be thinking about what are some things that I can do to make the time of that collision as long as possible, because the longer the time is, the smaller the force will be. So as you think about what your materials you're using, how you put this together, how you arrange your package, be thinking about what are some things that I can do given what I understand about this impulse equation. I hope that helps. If you have any questions, please let me know, and I can happily find some other way to explain this to you.